Sean, and I'm a Senior AI Product Manager at JSI. Thanks for joining us for part 2 of this video series titled AI Essentials for Investigative Intelligence, where we break down the core AI capabilities that matter for investigative work, show where they truly add value, and also give you a clear understanding for the considerations that should guide every deployment. Now, this episode in particular is going to cover natural language processing, or NLP. But before we get into it, let's quickly go over what we've covered in the series so far, and also where we're headed. So in part 1, we talked about the data problem that law enforcement and intelligence teams are up against and where AI fits into it all. Now, if you haven't watched this video yet, I encourage you to start there because it really starts to set the stage for what's to come in these later videos. Now in this part, we're going to start with the first AI subfield called natural language processing, explaining what it is and the ways that it can be used to help sift through massive amounts of data to pull out pertinent intelligence. Then we'll move on to other subfields like computer vision and generative AI. Part 5 will also discuss how these AI capabilities come together into emerging AI systems that help perform in real-world investigative workflows. And finally, we'll end on the compliance and ethics of AI in investigative intelligence. So now, let's start by defining what natural language processing actually is. So when we talk about natural language processing, or NLP, what we're really talking about is a subfield of AI that's designed really to help computers actually work with human language. So not in a keyword matching way, but really in a way that helps them understand the structure, meaning, nuance, and intent. Now, NLP really helps to break language apart the same way that humans naturally do. It analyzes grammar and interprets phrases and makes sense of context so that a system can really understand what someone is trying to communicate. Now, at its core, NLP is simply the bridge that lets machines understand human communication in a more human way. Now, where NLP really becomes truly valuable for law enforcement and intelligence work is in the types of data that you deal with every single day. Now, some very common and relevant ones are, of course, telephony. Natural language processing and specifically speech analytics technologies can transcribe and translate conversations and surface meaning or intent without requiring teams to listen to every single minute of audio. In messaging data, it can quickly make sense of text conversations, slang, or even coded exchanges that may take a lot of time to interpret. For surveillance audio, again, natural language processing and speech technologies can summarize long recordings and even highlight key segments so that investigators can zero in on what matters most. With things like body packs, again, natural language processing can help extract relevant dialogue from busy or noisy environments, easing the burden of reviewing long, raw recordings. And finally, with online activity, whether it's forums, chats, or social platforms, natural language processing makes that language searchable and easier to analyze at scale. Now, all of these sources produce huge volumes of human communication. And of course, natural language processing helps to efficiently convert that noise into intelligence that investigators can actually act on. So let's get more specific with some concrete examples of how this technology can be used within your particular workflows. Now, when we start talking about natural language processing and the types of data you're collecting, of course, a big part of that data will be human speech. So actually coming from recordings or videos where humans are actually talking with one another, not through a textual medium, but through actually communicating with their voice. Now, as a key part of an early NLP pipeline, you might need to incorporate tools like automatic speech recognition that can transcribe that spoken word into text data that can later be analyzed by other natural language processing type tools. So typically what this looks like is you will have transcriptions that are generated that have the actual spoken word, they have the timestamps associated with when those things were spoken, and we can even layer on additional capabilities like diarization to pull out unique speakers, and also speaker identification to figure out who is actually saying what. Now, of course, there's some challenges associated with this type of technology as well. What we've seen with the current state-of-the-art tooling is that things like silence and background speech, music in the background can create certain complications that will typically create less than desirable outputs. Other things like dialects for different languages that are being analyzed or blended languages within the same patch of speech can certainly as well create complications if the model's not been trained sufficiently on that source language that's being transcribed. And finally, of course, because this is the first step in a more holistic pipeline that analyzes that human communication, if there happens to be a problem with the transcript that gets generated up front in that pipeline, it's going to have downstream impacts on every other process that you run. So understanding the confidence scores and the accuracy generally of the transcript is kind of the first step in understanding how well things are going to work downstream when you layer on additional capabilities, such as translations. So again, with automatic speech recognition, you are transcribing spoken voice into the language that's being used. But if they're speaking in a different language, you might want to translate that content. A lot of research has gone into this space over the last several decades. Google Translate, lots of other tools that exist in order to do this, all leverage something called natural machine translation. So taking lots of example sets of one language to another and building models that can really help transform text in one language to the target language. Now, again, this can cause some challenges as well, depending on how these models are built. So typically what these are doing is a literal translation of every single word. And that can, lose nuance and lose meaning in the overall communication that's trying to occur that's being translated. Now, certain large language models are getting better at this, but it's certainly still not a perfect situation. And so, again, critically important that even though you might have natural machine translation running within your investigative environment, any intel that you identify that might be actionable or help lead to a decision should still be reviewed by that human translator or interpreter, really to be absolutely certain that the meaning is captured as you expect. Now, as we continue to analyze data, we also have other tools in our toolbox like sentiment or emotion analysis. Now, of course, what this can be very powerful with is identifying overall sentiments such as positive, negative, or neutral in general for individual text messages or posts on social media, or even again, conversations that have been collected through different audio sources. And again, what this can help with is just generally looking at trends, I'd say more than anything. So for example, we might be looking at a Facebook group and we can trend over time what their emotions or what their sentiment might be. And so that might be a good predictor for future activity. Maybe that particular community is becoming much more negative and angry over time. And that might be an indicator that we want to keep track of in order to make sure that we can keep tabs on any future events that might transpire. So certainly there are tools around sentiment and emotion analysis that can take into account how that text represents itself when it comes to these types of categories. Another really powerful capability that's in the toolbox is text classification. So again, as an investigator or an intel analyst, you might be looking for very specific types of data that bring up certain categories or topics. And so where text classification comes into the scenario here is that we can actually define key topics, key classes that are of importance to our investigation, whether that's things like meetings or narcotics, weapons, or threats, as an example. And what this does is it takes your input data. So in this case, it's saying, hey, buddy, if you ever come near my turf again, I'll make sure you won't be able to walk. And we can layer those categories we care about against this input data and then actually get a score for each one and how relevant that might be relative to the input content. And so in this case, you'll see that this particular model that we're testing here identifies that there is a strong possibility that there is a threat included within this statement. And so again, what you can have is this kind of tool run across large volumes of text data and help you very quickly identify just the content that might have threats within it, which may be a high priority focus for you. Now, of course, again, I want to make it very clear that these models are not perfect. And there is a concept of false positives that can occur, where it will tag a particular piece of data with a category that is actually not accurate. And so again, that stresses the importance of having human in the loop workflows where you are actually validating and reviewing the outputs of these models. So as an example, I have the exact same categories here, but I'm analyzing this new piece of content where I say, we're going to destroy them tomorrow night at the game, go team. Now, of course, this is not an implied threat, but still the model determines that there is a high likelihood that it's a threat. So in this case, we would consider this a false positive. So again, very important when you're evaluating and looking at these different types of models to run within your operational environment, that you do some benchmarking against real world data that you know has threats or you know has weapon references within it, and you validate that against what the model is doing so you really understand where it works well and also where the limitations are. Now, another really important tool that we have in our NLP toolbox, again, is also named entity recognition. So where this gets really valuable, again, is if you're pulling in large amounts of text content where there are entities referenced within it. And of course, entities are the focal point of any investigation or analytical workflow here in this space. And so what we want to do is be able to not only identify the specific entities that are referenced within the content, as we see here, we've got Harry, who's identified as a person, McDonald's as a location, Plainfield Street as a location, and also Bart as a person. But we also want to start to establish links between these things. So for example, we see that he went to see Harry and Bart, and so we can establish a relationship between the actual producer of this content or whoever sent this message, because they clearly know who Harry is and who Bart is, and so we can establish that link. But also we can do some additional downstream processing on these extracted entities. So for example, we found McDonald's on Plainfield Street. And so we can actually pull that out and run that through, say, a geocoding tool so that we can actually tag now location data onto this record as well. So further enriching the source data that we've collected to make it even more valuable from an analytical perspective. Now, if we actually put all of these examples together, again, I went over a number of different NLP tools that are available at your disposal, and we put that together into a workflow for a scenario investigation. What we'll see on the left is that there are a few, again, common data sources that investigators deal with every day, from text messages to emails and foreign audio files as an example. So let's focus on the audio in particular. So again, what we'll start with is speech technology using automatic speech recognition and how it will transcribe that conversation. So first, it detects the language and it transcribes it into the actual spoken text. Then what we'll do is actually run other enrichments downstream. So again, trying to translate that now into our operational language, which in this case may be English, but in your case may be different. Once we have that language translation and we've normalized that within our environment, we can then run things like entity recognition. So pulling out that there's a BMW referenced within this particular piece of text. And lastly, again, if we're going to use something like text classification, we can also determine that there may be a financial transaction reference within this piece of data. And so again, you can see that all of these things help promote these decision-ready insights within that one piece of text that we've ingested. And of course, you can scale this across millions and millions of pieces of content that you're collecting as part of your investigations. Again, whether it's coming from transcribed audio or social media and OSINT activity or other sources of information that are relevant to your investigation. So that wraps up part 2 on natural language processing. In the next video, part 3, we'll shift gears towards computer vision. So again, using AI to make sense of images and videos at scale so that you can help more easily spot patterns and evidence much faster. We'll then look at part 4, which dives into generative AI, and then shift into part 5, where we'll really start to focus on how these different AI capabilities come together into emerging AI systems for law enforcement and intelligence operations. And then part 6 is where we'll wrap up with a review of compliance and ethics as it pertains to artificial intelligence within investigative environments. So thank you again for watching. We hope to see you in the next part in the video series. And of course, if you want to learn more about JSI, please do visit our website at jsitelecom.com. Thank you.